Luis. Good morning, everyone. My name is Tarek Al Salah. I'm a member of the FIESTA IoT team, and I'm based at the University of Surrey. In this session, as Luis mentioned, I'll be presenting the FIESTA IoT ontology and the taxonomy that we use for describing our resources, i.e. sensors, essentially sensor devices. So when we came to defining our model for FIESTA IoT, we wanted to look at reusing concepts that are already defined out there in the semantic world. So we essentially found that one of the main ontologies used for describing sensors and observations is one called SSN, which maybe probably some of you are familiar with it. And we essentially took this as a base for the ontology due to its high usage and hence its likelihood to be interoperable with other semantic data sets out there. The thing with SSN is that it only focuses on sensor devices and observations. So what we needed to do to complete the story for IoT is that we wanted to also add another ontology which complements SSN, but also adds the necessary or the basic components of an IoT infrastructure. So in this case, we've also added entities, which represents objects of the world, whether physically or virtually, and also services. So which is an essential part in, especially in the internet part of the Internet of Things. So you need to be able to expose your sensor devices through internet compatible means, which essentially you would use technologies such as web services and also protocols and proxies to be able to expose your resources to the internet. So essentially, that's why we've added the IoT Light ontology. Also, on top of that, we wanted to consider the phenomena and the units that are captured and used to represent what the sensor devices are measuring or capturing from the world. So therefore, we've used a well-known ontology called QU, which essentially stands for quantity, kinds, and units. So basically, from these ontologies, we essentially just use you could say pruned versions. So we more or less took out the concepts that we were actually interested in. So we didn't basically adopt the whole ontology from these ontologies. We just more or less focused on what we actually need for FIESTA IoT. We also adopted spatial and temporal ontologies, of course, since it's a important aspect of describing sensor observations. So they need to have some kind of spatial and temporal context. And also we adopted ontologies that represents the actual values that you use to capture the values that represents the readings from these devices. Therefore, we've adopted the geo, time, and DOL or Dolce Light ontologies. And the other thing is that we, when we're defining our sensor devices, we also need to refer to a taxonomy, which then we can actually define in more detail what sensor devices we're actually using and what units we're actually using. And therefore, having a a hierarchical structure for this provides a good reference for defining sensor devices and giving them some kind of hierarchical context. We also had activities within the project to link to other ontologies. So there's one upcoming or which is expected to be a popular ontology in the IoT world, which is the 1M to M ontologies. So we've also had activities here for equating the classes defined in 1M to M with the classes used in the FIESTA IoT ontology. So looking at the FIESTA IoT ontology from a holistic perspective, essentially it's, as I said, made up of different ontologies. So essentially the first one is the SSN ontology, which allows you to define your sensor devices, where these devices are fixed. So essentially use a concept called platform to define where the actual devices are located, if they're on a table, if they're on top of a building or whatever. You also give a definition for its deployment. So you could, for any IoT infrastructure, you can have multiple deployments, not just one deployment. So you could have the same platform or IoT infrastructure deployed in different sites. So for each site, you'd probably give a different deployment name for that. And also, if you look towards the bottom here, here the observations are defined. So on the top part, it mainly focuses on the sensor and the system that the sensor comes under. And here at the bottom, it mainly focuses more on the observations and the values of the observations that are captured. So in addition to SSN, we also extend SSN to use IoT Lite, which provides definitions for services and also entities. So basically, entities would be what the resources are essentially monitoring. So here, as you can see on the right side as well, we also provide information about coverage. So if you could also define the coverage that the sensor devices are relevant to, which essentially is a spatial definition. So you could have it in the form of a circle or a rectangle or a custom like polygonic definition. So we also use ontologies used for defining the physical or social contexts. So in this case, we use the DOL ontology to define the observation values, and the observation values can have different forms. So they can be in doubles, booleans, doubles or booleans. And also we define the temporal values for these readings. So you essentially be able to provide the like a timestamp in the if I remember, it's the 8601 ISO format. If that's the right number, I'm not sure. But yeah, so that's the format that you essentially use to define the time at which the values were captured. So we also make use of spatial and also specific time ontologies. So we also make use of the GOWGS 84 ontology for defining your spatial context for the sensors. So essentially, you define a point, and each point would have a set of coordinates or a coordinate, and also you could also provide relative locations, which essentially come from the IoT Lite ontology. So the last component, you could say, component of the FIESTA IoT ontology is the M3 Lite taxonomy. So here, essentially, you define your sensor devices or actuating devices or tag devices, and here you'd essentially have a hierarchical structure. So so you'd have, for example, at the base, you'd have the or the top of the class, you'd have the sensor device, and then a subclass, you'd have a temperature device, and then a subclass of that could be, for example, a thermometer, and so on. So so we essentially have a hierarchical structure for that. Within the M3 Lite taxonomy, you can also define the domain of interest, which basically gives an indication of which domain this resource is being used in. So, for example, at the University of Surrey, we have the domain of interest with regards to the testbed that we have is a smart building testbed, a domain. So basically, you're able to also discover devices based on which domain it's being used in. The M3 Lite taxonomy also makes use of defining the measurement type, whether it's manual or automatic. So it basically defines how the observations are being captured. And also here, the M3 Lite taxonomy makes use of the quantity kinds and units as a base, and then also extends from that and defines specific units and quantity kinds which are relevant to the data that's coming from the testbeds. So here, basically, you've seen the ontology defined in a holistic manner. So basically, we have two perspectives when it comes to the main perspectives when it comes to the FIESTA IoT ontology. We have what is called the resource graph and the observation graph. So the resource graph basically defines the you could say the metadata or the information about the resources. So what you see here in front of you are basically all the properties and all the classes of properties that are used to define a resource. So essentially, you'd make use of the SSN device class, and then from that you would define properties relating it to the service that exposes it, the platform that it's fixed on, and the deployment that it's being used in. So with regards to the observation graph, this mainly focuses on the observations that are captured from the sensor devices. So here you would essentially define properties such as the quantity kind and the units that the observation represents, and also the actual values that the observation that the captured observation has. So with regards to the M3 Lite taxonomy, which is probably one of the most important aspects when it comes to discovering your devices of interest. As you can see here, you have at the top here you have the all the classes that are defined in the M3 Lite ontology with regards to sensor devices are a subclass of the SSN sensing device. As you can see here, we have a range of sensor devices from accelerometers to light sensors to to sound sensors, ultrasonic sensors, and so on. So basically, here's what you would want to refer to when you want to discover specific devices of interest. When it comes to quantity kinds or phenomena, here you basically you refer to the subclasses under the QU quantity kind. So complementing the devices. So for example, if you wanted to look for an accelerometer, you would essentially then look for the acceleration quantity kind. If you're looking for a sound sensor, then again you'd look for the sound quantity kind. So also in addition to the quantity kinds or the phenomena, you'd also want to provide the type of measurement that you want that represents the phenomena. So so here you have subclasses, for example, ranging from ampere to kilometers per second, to liters, to milligrams, and voltage, and so on. And then lastly, you have the domain of interest. So here you could also discover the devices based on which domain it's being applied on, whether it's being applied in an agricultural domain or a smart building, smart city, and so on. So this would be an example of a resource. So this is taken from one of the testbeds that are federated with the FIESTA IoT platform, which is from the Sound City testbed. So essentially, in the middle here, you'd have your device, which is a class SSN device, and you would instantiate it by giving it a URI, which gives usually some kind of useful meaning here, or a reference to its ID or something similar to that. So essentially, here you'd have your device, and then you define where it's on what it's deployed on, the platform that it's fixed on. So again, for each platform, you define the spatial context for the platform. So if it's deployed on a building, you provide the coordinates of the building here. And then here on the left side, you define the domain of interest. So in this case, this is rated to the health domain. And for your device, you could also have subsystems which essentially define the sensor devices that you use. So in this case, a sound sensor is being used here, and for each sound sensor, you define the unit, the quantity kind that it captures, and the unit that the phenomena that the phenomena is used to quantify the actual phenomena itself. So here is an example of a observation annotation. So essentially, you start here. You define an observation, give it some kind of useful URI that's usually readable. And then from here, you would say basically where this observation comes from. So essentially, you would link it back to the sensing device that was defined here. So so then basically you provide this link between observations and resources, which is important, especially in the context of linked open data. So again here, so when in addition to defining your relation to the sensing device, you define for example here the location at which this observation was taken, and here you define essentially the observation value that was captured, and then you'd also link that to the unit as well. You can also define other properties such as the measurement type. So in this case, the measurements are taken automatically, so not in a manual manner. And also you could define the source at which the observation is being captured from. So when it comes to publishing data to the FIESTA platform, we provide a guide. Yeah, we provide a guide for the best practices in order to publish data. So essentially, we tell test providers to not use blank nodes. So they should create individuals which for each of the concepts that are defined in their annotations. They should provide meaningful URIs for the individuals. They should respect the cardinality, so they don't create, they don't go against the cardinality of the ontology that's defined in the IoT, that's defined for FIESTA IoT. They shouldn't push unnecessary fake or test data. So make sure that they're sending out useful data or real data, and you also advise them to make use of the validation services and the certification services that are available through the portal. And we also tell them to remove concepts that are not actually used. So basically, we ask them to keep it on a a need to know basis, so not to over describe their senses if these descriptions will not be useful or relevant to the FIESTA IoT platform. So yeah, that's more or less that. So I guess what the most important thing is that for experimenters, when they want to query for data sets, so essentially what you'll be using is you'll be using the Sparkle language for that. So I won't be explaining this here, but essentially Sparkle is something that's similar to SQL for those who don't know. So when you're making your queries, your results can be in several formats. Can be so if you're making what is called a select kind of query, you could retrieve your results in CSV, in JSON, or in XML. But if you're wanting to retrieve semantic or data in semantic form, you'd usually use the methods such as describe and construct in your query. And here you'll be able to get data back in RDF in these different variants here. So JSON LD, RDF XML, RDF JSON, and Turtle. So just to conclude here, so ontology documentation is available at these links here. So we'll be able to browse through the ontology and the taxonomy in more detail. There's we have the IoT registry, which is essentially the repository that you'll be getting your data from, which all the data from the test beds will be going to. So you're able to query the IoT registry for the data sets that you're interested in. So the APIs essentially, or the documentation for the APIs are available in the link here. A bit of information about IoT registry, that it's a Jena-based store. So we use an Apache. We use the Apache Jena library for creating our triple stores and the interfaces for those triple stores. We also have a paper that's been published maybe just under a year ago, which you could find here, which talks about the ontology as well. We have 2 deliverables available on request and a handbook that is also available via the Moodle platform. I won't really go into this. Basically, when it comes to when you have testbed providers who examine or review the taxonomies, they sometimes don't find the phenomena or units that are relevant to their testbed. So we provide an update process for them to actually to do this. So we provide them like a form for them to fill in, which then they can describe what the requirements are in the format as described here. So I really won't get to that since I'm really past my my slot. So I'll just pass that. So that's really it. Thank you very much, everyone. Just wanted to ask if there's any questions. I'm